recording now. Not even going to do an audio sync. All right, let me share. All right, so and start sharing. Okay, so since 13 deals with like doing like getting a new shape that's going to be a child of another shape, we can actually use any of the game engines. So if I go to classwork and game engines, go ahead and just download engine 2.1. And like everyone that wants to follow along, go ahead and do this. If you already did it, you don't have to follow along. But if you didn't do the homework, I please, because I will give you a 0, especially after literally going over it in class. And I don't want to do that, but please do that. All right, so everyone go ahead and click on this. Which I know, like, it's a little bit confusing downloading some files from Google Classroom. Like, it'll bring up a menu like this. You have to click on the 3 dots, open in a new window, and then it'll give you this little download icon, and you can begin downloading the file. And then, since this is a zip file, you have to extract it. And let me see. Didn't have this one extremely well organized. And what was the number on this one? 13. Yeah. And yeah, I lost my paste. Copy. Really? Just a second. Like, I only recently today went back to using Linux because I wanted to do some AI stuff, and like some things work so much better in Linux. Homework 13.
Aren't the Chromebooks like a variation of Linux, like the Chrome OS?
In the strictest sense of the term, yes, so is your phone.
Okay.
But that's like saying like this cable pox runs a variant of Linux, therefore it is Linux. Like, yes,
Oh,
yeah, that I think that's an important thing to mention. Despite it doing that, it's built to do very specific things. You can actually put Linux on those Chromebooks. Like you
yes,
could,
I saw that. That's why I asked.
like I've actually been, I was tempted to ask IT, like, hey, I have a student that needs a laptop, like a real laptop, not a Chromebook. Can I get permission to go from Chrome and put Linux on like 1 or 2 Chromebooks? And like it was just a non-starter. They like if it gives kids the ability to do anything outside of like what they would normally like to control, they don't like it at all. But you know that's IT.
They even
Uh,
block Chrome dinosaur game, like,
oh
ugh.
really?
Yeah, like the offline game. Like you can't play it offline.
Bruh.
It's very sad.
All right. So make sure you go ahead and extract this and get Visual Studio Code up and running. Let me also close these. And make sure you close any folders that you have open, and then open the new workspace. All right. So this should be the starting point where you have the engine 2.1 folder open that you extracted with the files of main util, main prog, main HTML, game util, and game prog. And this debug file, which I didn't intend to actually put in there, but it was put in there anyways. All right. And, of course, the images folder. All right. Jaden, go ahead and tell me once you've gotten to this point, and we'll switch to your screen.
I got it all set.
All right. Yes, this is going to be for polymorph. Let me go ahead and stop presenting. Jaden, if you don't mind, would you go ahead and start presenting? And let me make sure this is... Okay, good. The camera's picking it up. Okay, let me drag that away. All right, we should... All right, so let's go ahead and... so the general organization of this engine is supposed to be the game... so anything prefixed with main is supposed to be like core game engine stuff. And prog is anything with the ending prog is intended to be something that has something that's run, like a function that's run, and anything that's util is intended to have objects in it. And so anything prefixed with game is intended to have game-specific logic to the particular game that's being built. So that's the very simple sort of organization to this very, very simple game engine. So let's go ahead and go to main util for a second and look around. Also, a quick question. Is this on, like, your monitor, like, is it, like, really squished, or, like, the resolution's kind of weird on my end?
Oh, that's because I have it, like, half and half.
Oh, okay. Is there any way you could make it full, since you're the one displaying right now?
Yeah, I'll adjust it.
Excellent, thank you. All right, so we've got all sorts of objects here, which we're going to explore in more detail, but go ahead and scroll down, and towards the bottom, we should start running into the collidable objects. All right, there we go. We're in the collidable territory. So let's scroll up until we get to the top of one of the objects. Okay, so there we go. Rectangle's a great example. So collidable is because JavaScript doesn't have something called interfaces, which if we were using TypeScript we could use, where you could define like all objects should have these methods. I created this thing called Collidable, which isn't intended to be used other than through inheritance. That Collidable just has the idea of collision, and everyone's supposed to inherit from it. And anything that uses like a collidable that can check to see if it's collidable can be guaranteed that that object will have certain methods, that it knows those methods will be there. Like one of those methods, let's scroll a little further up. Let's get to collidable itself. All right, there we go. So collidable, like anything that inherits from collidable is guaranteed to have contains, intersects, and translation copy. Contains is literally like anything that inherits from collidable. You can go ahead and give it another collidable, and it is supposed to correctly determine, hey, does this object contain this other spatial object? Intersects is similar. It's checking not full containment, but is there an overlap of any kind that it's going to return true. Translation copy is intended to go ahead and take the object, you go ahead and feed it a vector, so like positive x, positive y, that translates it to a new location and gives you a new copy of that. This is extremely useful for physics and things like that, where like you have some sort of collision thing, and I want to determine, hey, is this, like, I have some velocity to my object, and I want to apply my velocity and check to see, is this new area a valid location? And if it is, then I'm going to go ahead and put it in, like, make this new translation copy the current one. So we don't necessarily need translation copy. It just makes code simpler in other areas. So let's go ahead and scroll down to, I think, point 2D. So point 2D like added a couple things just for quality of life, like distance, which it will tell you the distance between one point and another point. Which can anyone in class tell me what formula is, like the name of the formula on line 290? That is correct, as silly as it is. Yes, that is the distance formula. Which the distance formula actually scales in infinite dimensions. Like, this same idea can be applied to 3 dimensions, 4 dimensions, though a game in 4 dimensions is kind of hard to think about. But the amazing thing about math is it scales. So we could kind of make like a 4D game. There kind of exist ones, but they're more, I would consider, experiments in computer science than actual games. I heard, there was a wonderful one that explored multi-dimensional, it was, I think, a 5-dimensional game where it was kind of like Paper Mario, and by rotating or being in certain orientations, you navigated a multi-dimensional maze. It was like really cool, but I don't think it was a great game. Uh, it sounds super cool, but if you actually played it, it's not fun. There's a difference between this idea sounds cool and this idea is actually fun to play. Like they might have been able to make it a fun game, but eh. All right, and let's scroll down to the contains on point 2D. All right, so in oh yeah, I actually just made the blanket statement that points cannot contain anything because they don't contain area. But the intersects, you can look and see like how the intersects works. And I was actually a little bit lazy there. In most cases, I'm like, hey, since this is a point, if the other shape contains the point, that means that the point intersects the thing. Yeah, extra-dimensional stuff can be like really, really cool, but making it into like a fun play experience, I have yet to see a game that does that. Like maybe one of you will do it, but eh. All right, so that's the basic idea here. So let's go ahead and go in. Let's make a new file. And let's call this myutil.js. All right, so let's do our work in here. So what sort of shape would you like to make like for collision?
You like asking me?
Oh yeah. So Jaden, and the easiest way to do this would be like to make it out of either existing like shapes that we have, because if we make it out of existing shapes, we can use all of the collision logic in those shapes because we can reuse code. That's the beautiful thing about object-oriented programming is code reusage. So actually, let me rephrase that question. So if you could make a shape out of any combination of, let's say, rectangles and or circles, what shape would you like to make?
We'll use the rectangle because that just seems like the best kind of collision type shape.
All right. Let's go ahead and I'd actually go ahead and give back control for a second, and let me bring paint over here.
Didn't we use the T block as an example? And,
Yeah, previously
first
we
time?
used a T block, but I think so. I would actually like to do a slightly different example to give people an interesting concept of what can be done, because the T block was just adding space. We can
So
actually,
we can get more complex.
yeah, we're going to make this one a little more complex. So
Yay.
let us assume that like we make this rectangle. So this is going to be rectangle A, just to make it easy to talk about. And let's say the shape I ultimately want to make is going to be this open sort of thing here. So I want to do collision for this. But I only have rectangles. So let me also get rid of A for a second. And that. We'll just deal with transparency existing on the sheet, or yeah, I'll just deal with transparency existing on the sheet. Anyway, so let's say the only thing we have are rectangles, and we can determine if there is any sort of containment or collision within those rectangles. So how can we use like our existing technology to make a collision shape like this? So does anyone have a suggestion?
I do.
Go on.
You can just use the whole rectangle, then you subtract another rectangle from that rectangle.
Very good. So let's say we have rectangle A, and we're going to define in terms of a rectangle which we're going to call B. And what we're going to do is, like when there's collision, we're going to say, hey, if... So this is the not symbol I'm trying to do, which is an exclamation part. So not B... So if collision not B, and sorry for the terrible handwriting, and that looks terrible, and A. So if we have collision on A and not B, therefore we have collision in this U shape. So that's the general idea we're going to go for with this. So let's call this a U shape. So Jaden, if you don't mind, would you go back to presenting? So let's go ahead and make a class called U-shape, and I would like it to have a rectangle as a parent. So if you don't remember, let's also, do you remember how to do that, Jaden?
Not particularly. You just start with class.
The rest of the class, what sort of suggestions do we have?
Don't you do U-shape, class U-shape extends rectangles?
That is correct. Let's go ahead and do that.
On a U shape.
Yeah.
What else?
Extends rectangle.
Also, if you don't mind, could you zoom in just a smidge?
Yeah, let me see how I do that.
Do Control plus.
Oh, okay.
A little bit more. It doesn't. I want it to show up well on the video. Okay, that's good. All right. Continue with extends, please.
Does extends rectangle I'll have to be one thing?
You are using extends correctly, but remember that objects use uppercase camel case. So what's wrong with your rectangle? And
Lowercase rectangle?
no, it's uppercase rectangle. Go ahead and hover over rectangle for a second. Oh, okay. It's complaining about lack of brackets now. Go ahead and also make the U capital in U shape. Because we want to try and follow that convention. And then go ahead and give this start and stop brackets. All right. So let's go ahead and, since all our code is going to be contained within those brackets, where do you think those brackets should go? All right. So, class, what do we need next?
The constructor, right?
Yeah.
Correct. So, do you remember how to make a constructor, Jaden?
No.
All right. How do we do that?
Constructor, and then the arguments. Would it just be x and y since it's just a rectangle?
Yeah, it's x, y, width, and height.
Okay.
Yeah. So let's go ahead and, since we want arguments for our constructor, let's go ahead and do parentheses, start and stop. Very good observation, Grayson. That is very correct. We do need to use super inside the constructor. So, do you remember, Jaden, how to do arguments inside a constructor?
No.
So, what we do, so this language, because it's loosely typed, we just state the name of what we want the arguments to be. So we're going to go ahead and write x, comma, y, comma, w, comma, h. So this is going to act as the x and y coordinate of our box and the width and height. So
Is it lowercase or uppercase?
we're going to do lowercase. So for the most part, anything that's not an object uses lower case camel case, where the first word is lowercase, and then every other word. Let me type out some examples, like hello. So if I had, say, a attribute, hello world, that would so world is the second word. So it, like, I capitalize the first letter in the second word, and we can immediately and we live in a community too. Memes abound. But we can immediately tell what is a class and what is either a property or a method of a class by going with that kind of naming convention. So after the constructor, this line right here, what do we need to put? What does almost everything in this language start and stop with?
Brackets.
Yep.
Squiggly brackets.
Yes, squiggly brackets, which my favorite description from a student ever has been that needs squiggly boys.
Yes.
Oh, and if I ever make a programming language, I'm definitely going to include that somewhere in the syntax somehow, and I'll credit that student. Let's go ahead and do a new line. And add some brackets, start and stop. Squiggly brackets. Alright. So, Grayson hit the nail, the head on the nail, blah, blah, blah. We need to use super. Because rectangle, we're extending rectangle, so the first thing we need to do is super. So let's go ahead and do that. And there's one slight problem with your super, Grayson.
We don't have lights, do we? We have width and height.
Yeah, we have width and height. Let's actually. I want you to go ahead and Jaden, go to like main util for a second, and scroll to where rectangle is. It should be further down. There we go. So rectangle. Look at the constructor for rectangle. Look at what it needs. And a super, whenever you use super, you need to put in all that stuff. So what do you think the super in your object's going to need?
Don't know. Just the coordinates?
Yeah, it's going to need the x, y, width, and height. So let's go ahead and go back to my util. And type out super. Start and stop parentheses. All right, and you see the little tooltip you've got?
Mm-hmm.
Does that give you an indication of what you need to type here?
Yeah.
All right, go ahead and type it. Quick point. So what it's doing there with the full colons, it's trying to tell you the data type, which since this is pure JavaScript, the data type is always any, which means anything you jam into it is considered quote unquote valid. So go ahead and do x comma y. Yeah, there we go. So, and then go ahead and continue how you think it should be done. Yeah. So our constructor for our U-shape is going to go ahead and have the x, y, width, and height. But we want to go ahead and do a semicolon at the end. All right. So now, like if we wanted to add more logic to our constructor, we definitely could. And there's a lot of ways we could go about this, but let's go ahead and define our inner rectangle in terms of whatever sort of rectangle we're given. So let's go ahead and make a new method inside this object. So let's go ahead and go outside of the constructor and go ahead and get me some space outside of the constructor. We have left the object, so good. So the first thing we need to do is make a translation copy. So method. So class, assist with making the translation copy method, please.
So it's a function. So you do translation copy, and then the parentheses, not parentheses. Parentheses, and then the argument. What was the argument?
Let me make a quick correction to what Jane was doing. So when you're defining methods inside of a class, you don't actually have to state function. It actually is an error to do so. So we just go ahead and state the name of the function. Good. And go ahead and continue.
Isn't it because if you like put function, it thinks that you're making a new function?
Yes. That it thinks that it's naming a completely new function within the scope, which the scope inside of a class is like weird when you're defining a class. Go ahead and humor me. Go to main util, and I'd like you to look at the translation copy for rectangle. Scroll a little bit down. Look. So, go ahead and let's get some more real estate. So the file menu on the left, could you go ahead and drag, make that disappear. Good. Like, drag it over. Should be able to make it completely disappear. There we go. All right, so now we got it all on screen. All right, so translation copy, we're taking in a P, which must be an instance of point 2D. So we're treating this 2D point as if it were a vector. And what do you think we're doing with that point?
We're copying it and translating it.
We're not really copying. Well, we're copying and we are making a copy of the rectangle, which is a translation. But look at by what amount are we translating our rectangle? Like look at the code that's on line 436. So look at that that newing that we're doing, and think about that code.
What does P reference again?
P references the point that we're taking in as an argument, and P is acting as a vector. So it strictly is a point, but since it has an x and a y, we're just treating that point's location as a magnitude in x and y.
So it's making a whole new rectangle.
Yeah, it's making a whole new rectangle, so that's what the return new rectangle is doing. And look at the arguments that we're using in this constructor. So this dot top left dot x. What is this dot top left dot x?
The top left point of the original rectangle?
Yeah, that's precisely what it is. And look at we're adding to it. P dot x. So I'm taking the original rectangle and I'm adding that P dot x for the translation. The same thing is happening with this dot top left dot y plus P dot y.
So would it be like diagonal since it's adding x and y?
Assuming that there's a non-zero in the y and x. So let's say translation copy is called with a point that has x equals 4 and y of 0. Would that be diagonal?
Oh, no.
Yeah, this allows us to make a new rectangle in any direction based upon the incoming point. So I want you to actually really take in this function. Like it may look complex, but the amount of stuff going on is actually kind of low. We are taking for the first and second arguments of the new rectangle, we're adding the current top left x and p dot x. We're adding that to go ahead and translate the new shape. Now, Jaden, when you look at that code there, does that make sense, or is it just utterly confusing?
It sort of makes sense.
All right. So in this case, we're doing the translation copy, and that if p instance of, that's just making sure that p is a point 2D, because that will go ahead and guarantee it has a p.x and a p.y. Strictly speaking, that if statement isn't absolutely necessary. I think it's good practice because it'll stop us for getting an error. Though if we might, at some point do try catch. At some point we may actually want to put something in an error log to say, hey, this method was called in a completely improper way. Maybe you might want to look at this code. So let's go back to myutil.js. So we need to take in an argument, and it's supposed to be a point 2D. So go ahead and give it an argument of p. Alright, so inside this method, we need to go ahead and return a translated copy of the U-shape. And keep in mind, we actually made this really easy because our inner rectangle that we're subtracting out is defined in terms of the outer rectangle. So what do we need to do on line 9?
Sorry, I had to tell my mom something.
Okay.
What was that?
So what do we need to do on line 9? So we need to we need to return a new copy of the U-shape, but translated by P.
Or do we have to recreate that if statement?
Yeah, the if statement is a good idea. It is a safety measure that stops us from taking in a p which is not a point 2D. So let's reproduce that if statement. Go ahead and give me start and stop brackets, and then I'll make one more point, and then I'll pause for the end of class. All right. So, quick question, Jaden. What do you think instance of does?
Checks if there is an instance like of the thing.
All right. So, what if I were to give it, say, something that wasn't a child of point 2D? So, let's say I give it a collidable, something that's a parent of point 2D. What do you think p instance of collidable will, what will that translate to? Like, if I do that expression, what do you think it'll evaluate to?
I don't know.
Mm. So the very important thing to know is, one, whenever you do some sort of variable instance of and then a class name, that's always going to evaluate to true or false. That's how instance of works. And it's only going to evaluate to true only if it is an instance of that exact object, or the object to the right, the class to the right is a child of that class. So if I made a point 3D, which had point 2D as a parent, I could do p instance of point 3D, and that would evaluate to true. And I could be guaranteed to have an x and y on my point 3D. Now, if I did p instance of collidable, collidable is a parent to point 2D. It is not a child of point 2D, so it would evaluate to false, because collidable doesn't have the stuff that point 2D has in it.
Oh, okay.
Right. So, sorry this went a little bit slow. We'll pick up the pace a little bit next time. But this stuff is super important, not just for knowing how JavaScript works and making complex things in JavaScript, but all object-oriented languages. These concepts are super important. I kind of wish we were in Java because I think the inheritance works better in Java, but whatever on that. Any questions before I conclude class?
Are we gonna do this more on Thursday?
Yeah, we are gonna go through the entire homework backlog until we are completely through it. I'm sorry about slowing things down, but it is super important to make sure everyone fully understands all of the previous homeworks. And if they don't, we need to stop and we need to readjust what we're doing. Okay. All right. So I'm gonna go ahead and turn off